Hi everyone, in today's lesson we're going to talk about the third type of Riemann sum, a method for approximating the total area underneath the curve. So today we're going to talk about midpoint rectangular approximation method, also referred to as Mram. So still same concept as we've been doing for the past couple of days. We're always going to give you an interval from A to B. And now what you want to do is you want to estimate the area under this curve through this interval. But I want you to use the midpoints of the rectangles. So if you look at these values here, here, and here, these are the heights of those rectangles, and those heights are found by taking the midpoint down here in the middle of each of the rectangles. So this height of your triangle is drawn by going to the middle of each of these subdivisions. So that would be how we will estimate the area using this midpoint method. Again, it's still estimating this actual area of the integral from A to B of f of x, right? This is your actual area over A to B, right? That's your actual area. That's your integration, okay? So let's do an example so you can actually see what it looks like. So again, same exact problem as we've been doing these past couple of days. So I'd like you to draw another picture. So we have the example, f of x equals 2 over x. So again, we've got same situation. All right, and this time, still the same concept, I want 3 subintervals over the interval from 1 to 7. So again, first step, we're going to find our width. So the width of each of the triangles is b minus a, so 7 minus 1, over the number of rectangles or subintervals, which will be 3. So 7 minus 1 is 6, 6 divided by 3 is 2. So now I want to use that to calculate the area. So again, I'm going to put down here 1, 2, 3, 4, 5, 6, and 7. But this time, between the intervals from 1 to 7, I want to use midpoint Riemann sums. So each of my rectangles will have a width of 2. So let's first analyze where that would be. So from here to here is a width of 2. I'm going to use a different color now. From here to here is a width of 2. And from here to here is a width of 2. But when I connect the rectangle up to your graph, you're going to use the midpoint of each one of these intervals. So from 1 to 3 has the width of 2. 2 is the midpoint. So you're actually going to go up to the graph at 2 and draw out your rectangle according to that height. So it's like you're using the height from the middle. That's what midpoint would mean. So now we're at the next rectangle with a width of 2. 4 is the midpoint, so we're going to take the 4 and draw our rectangle height according to the 4. Then we'll go to the next one in the middle, which is 6, and we draw our rectangle. Now, we don't ask you to over or under approximate using midpoint because there are spots where it's an over approximation here, but it's also an under approximation here. So it's not really fair to ask that question for midpoints. So to find the heights of the rectangles, each one of these, we need to find the height at 2, the height at 4, and the height at 6. So I need 3 different heights now. So here, here, and we'll say here. Sorry, that's not the best picture. So we're going to put this back into our y equals, so the 2 divided by x. But this time in the table of values, I need the x value of 2, 4, and 6. So why don't you go ahead and pause the video and try to see if you can get those y values. Okay, so 2 divided by 2 is 1. 2 divided by 4 is 0.5. And 2 divided by 6 is 0.3 repeated. So at x equals 2, we have a height of 1. At x equals 4, it's 0.5. And at x equals 6, it's 0.3 repeated. So if I want to calculate the area, let's start with rectangle number 1. So rectangle number 1 has a width of 2, but a height of 1. So 2 times 1. Plus, the next rectangle has a width of 2 and a height this time of 0.5. Then we're going to add to it the last rectangle that has a width of 2 and a height of 0.3 repeated. Let's use 4 decimals, 1, 2, 3, 4. So go ahead, pause the video, type that into your calculator, and get me the estimated area. And then hit resume when you're ready. Okay, so you should be getting 3.6666. Now, if we want to round to the nearest thousand, that's 3 decimal places, so 3.667 units squared. Now, I think midpoint approximation is a good average of the left and the right, so I think our actual area should probably be relatively close to this, but we're not going to know that until I show you how to calculate this integral by hand. So for now, let's just focus on getting the answers. All right, example number 2. All right, so same situation. We have radical x, so I'm just going to draw a picture. And I want radical x between the interval of 0 and 1. And I want 2 subintervals, so I want 2 rectangles over that interval. Okay, so first things first, let's find the width of each of the rectangles. So remember, it's b minus a over n. b is 1, a is 0, n is the number of rectangles, which is 2, so 1/2. So same thing now, and my rectangles will have a width of 0.5 and a width of 0.5. So now it's time to calculate the area. And we're going to calculate the area using midpoints. So same thing as we did before. My rectangle will go from here to here. Then my second rectangle will go from here to here. Both of these rectangles will have a width of 0.5. But I need to use the middle here and the middle here to make my rectangles. So the middle of 0.5 is actually 0.25. And the middle of 0.5 to 1 is actually 0.75. So when I'm making my traveling to the point on the curve, you're using the 0.5 as my height, so this will be my rectangle. And then over here, I'm actually using the 0.75 as my height, and that will be my rectangle. All right, so let's go back to the y equals, and let's type in our square root of x. And if you could, please get me values at 0.25 and 0.75, and then hit resume when you're ready for the answer. Okay, so at 0.25, you should have gotten 0.5, and at 0.75, 0.8660 is fine. So this height here at 0.25 was 0.5, and the height over here at 0.75 is the square root of 0.75, which is 0.8660. So if I want to calculate the area, the width is still 1/2, right? The width hasn't changed, that's 1/2. The height in this time is 0.5. So width is 0.5 and height is 0.5. That's the first rectangle. Second rectangle, width 0.5 and height rad 0.75 or 0.8660. So go ahead, type that into the calculator, and then hit resume when you're ready for the answer. All right, so you should have gotten 0.683 actually, which is perfectly rounded to the nearest thousandth, and we should write units squared. So that is your area using midpoint Riemann sums. Take a look at the left and the right and see if this 0.683 is somewhere in the middle, because that should make most sense, right? It's halfway between the left Riemann sum and the right Riemann sum. All right. If you guys have any questions, now's the time to jot them down. If not, we'll see you in class tomorrow. Have a good night.